friends, I welcome you all in this session. As you are aware, in previous session we were discussing hypothesis testing of proportion for two samples, and we have worked out couple of examples using Minitab. So, I am going to give you two questions here for your let us say work home assignment, and I would request all of you to solve these two questions, right. And the question number 1 is like this: two different areas of a large eastern city are being considered as sites for daycare centers. Of 200 households surveyed in one section, the proportion in which the mother worked full time was 0.52. So, proportion was 0.52. In another section, 40% of the 150 households surveyed had mothers working at full time jobs. So, 40% out of 150 households, it means 60 women out of 150 households, right. At the 0.04 significance level, is there a significant difference in the proportion of working mothers in two areas of the city? So, you just frame null hypothesis and an alternative hypothesis. You can solve it using critical value approach or p value approach or confidence interval approach. So, this is the solution, but I am not going to explain this because we have worked out several examples of this type. Similarly, let us look at second example. The Coffee Institute has claimed that more than 40% of Indian adults regularly have a cup of coffee with breakfast. A random sample of 450 individuals revealed that 200 of them were regular coffee drinkers at breakfast. What is the probability value for a test of hypothesis seeking to show that the Coffee Institute claims was correct? So, what is the claim of Coffee Institute? More than 40% of Indian adults have coffee at the time of breakfast. So, null hypothesis and alternative hypothesis you are supposed to frame and then solve this question. So, this is the solution. I am not going to explain this solution, you just work out using Minitab. And let us move on to exercise on hypothesis testing. So, there are several statements and you have to tell me whether these statements are true or false. So, let us look at first question. A paired difference test is appropriate when two samples being tested are dependent samples. A paired difference test is appropriate when two samples are being tested are dependent sample, true or false. This is a true statement, right, because in the very first class we have talked about what is dependent sample and independent sample, right. Let us look at second question. A one-tailed test for the difference between means may be undertaken when the sample sizes are either large or small and procedures are similar. The only difference is that when sample sizes are large, we use normal distribution, whereas t distribution is used when the sample sizes are small. Just read this question once again and try to answer. Is this true or false? No, this is completely false statement. Whether we use normal distribution or t distribution, it not only depends on sample size, but other parameter as well, right. So, that is why this statement is false. Let us look at third one. In testing hypothesis about the difference of two means, suppose that the sample sizes are large we do not know the actual standard deviation of the two population, we do not know, right. So, we do not know the actual standard deviation of the population, we can use the sample standard deviation as estimates. Is it true or false? If we do not know the standard deviation of the population, then we use sample standard deviation to estimate population standard deviation. This statement is true. Let us look at fourth one. If we took two independent samples and performed a hypothesis test to see whether their means were significantly different, right, we would find the results very similar to a paired difference test performed on the same two samples. What do you think? So, there are two samples, two independent samples, and you have performed hypothesis testing of means and you found some result. Now, would you find the same results if you take those two samples as dependent sample or related sample? Will you find the same very same result? No, this is false. You will have two different results, right. Let us look at the next one. When doing a two-tailed test for the difference between means, two-tailed test for difference between means with a null hypothesis as this, the hypothesized difference between these two population means is 0. Is it? Do we hypothesize that the difference between these two population means is 0? Yes, we do. So, this is true, because we always say mu1 minus mu2 is equal to 0, right. So, either you say mu1 is equal to mu2 or the same can be written as this, is not it, mu1 is equal to mu2, right. So, statement number 5 is true. Exact probability values can't be determined when using the t distribution in a hypothesis test. Is it true or false? Exact probability values can't be determined when using t distribution in hypothesis test. Yes, this is true, right. Let us look at next one. Two sample tests are used to reach conclusions. Two sample tests are used to reach conclusion about the relationship between two populations. Is it correct? Two sample tests are used to reach conclusion about relationship between two population. Yes, this is absolutely true. Okay. Let us look at the next one. When the sample sizes are small, only one tail test of the difference between two population means can be used. Is it? When sample size is small, do we use only one tail test? No. In fact, one tail or two tail test has nothing to do with sample size, is not it? So, this statement is false. Number 8 is false. Okay. Let us look at 9th. When the null hypothesis for testing the difference between two population proportion is this, when null hypothesis is this, you combine the two samples to estimate the common population proportion. Do we really combine? You combine the two samples to estimate the common population proportion. Yes, we do combine. So, 9th one is true. Let us look at 10th one. Most computer statistics packages do not give prob values for hypothesis tests. So, you still have to use table to decide whether to accept or reject null hypothesis. Is it correct? What do you think? Most computer statistics packages do not give prob values. In fact, the other way around is correct. They do give prob values, right. So, this statement is false, right. 10th is false. Let us look at 11th one. In testing the difference of two population means, in testing the difference of two population means, the null hypothesis must be mu 1 equal to mu 2. Is it necessary that null hypothesis has to be mu 1 equal to mu 2? No, there are in fact, we have seen examples where you can have null hypothesis like this, or you can have a null hypothesis like this, is not it. So, you can have all kinds of symbols in null hypothesis. So, this is false, 11 number is false. Okay. Let us look at the 12th one. If the sample sizes are too small to use normal distribution for test of the difference of two population proportion, you should use the t distribution. Is it? If the sample sizes are too small to use normal distribution for test of the differences of two population proportion, you should use t distribution. No, this is false. Again, as I said, whether to use normal distribution or t distribution, you look at sample size as well as population standard deviation. Let us look at 13th number question. If you use prob values, you do not have to specify a value of alpha before sampling. If you use prob values, you do not have to specify, yes, this is true, there is no need to specify alpha before sampling, right. So, 13th is true. Okay. Let us look at 14th one. To compare two population means using small samples, you should always pool the two sample variances. Is it? To compare two population means using small samples, you should always pool the two sample variances. No, this is false. We do not pool the two sample variances, right. Let us look at 15th. Testing the differences between means with dependent samples becomes a one sample test once you compute the difference of the paired observation. Testing the differences between means with dependent samples becomes one sample test once you compute the differences of paired observation. Yes, this is correct. 15th is true. In fact, we have worked out one example wherein we had a situation where gym instructor, the fitness training center instructor claimed that the weight loss would be more than 17 pounds, right. So, and then we framed null and alternative hypothesis as just one sample rather than two sample, right. Let us look at 16th one. Although you do not know how to do small sample test for two independent means when the two population variances are unequal, right, they are unequal. Most computer statistical packages will perform test in those circumstances. Is correct? Yes, this statement is correct. Statistical packages will perform test in those circumstances where variances are unequal, right. Let us look at 17th one. Paired difference tests of means can be based on either the normal or t distribution depending upon sample size. Paired difference tests of means can be based on either normal or t distribution depending upon sample size. Yes, this is true, right. Okay. So, we will move on to next slide, and next question is this 18 number. Prob values can be used for one sample test, but not for two sample test, is it? No, this is false. Prob values can be used for both one as well as two samples, right. Very simple question. Number 19. To standardize the observed difference of sample means when sigma 1 and sigma 2 are not known. To standardize the observed difference of sample means when sigma 1 and sigma 2 are not known, you always divide by this regardless of the sample size. Is it so? So, 19th is true. Yes, we divide it by standard, the difference of standard error, right. So, 19th is true. Let us look at 20th. Because most computer statistical packages report two-tailed prob values for tests on means, you must divide the reported prob value by 2 if you are doing one tail test. Yes, we have to divide it by 2. So, this is true statement. Question number 20 is true. Okay. Let us look at the next one. In testing the difference between two proportions, the divisor used to standardize the difference between sample proportion is different for one and two tail test. In testing the difference between two proportion, the divisor used to standardize the difference between sample proportion is different. Is it? No, I do not think it is different, it is same, right. So, this statement is false, right. So, it is same for one and two tail test, right, it is not different. Let us look at 22nd. Suppose you are going to test the difference between two sample means which you have calculated as 22 and 27, right. You wish to test whether the difference is significant. What value of this will you use? It is 5, -5, 0 or cannot be determined from information given below. So, value of this, right, will be 0 in this case. Okay. Let us move on to question number 23. Why do we sometimes use paired as opposed to independent samples? Why do we sometimes use paired test as opposed to an independent samples? What is the reason? Taking paired samples always costs less than taking independent samples. Is this the reason? Paired samples allow us to control for extraneous factors. Extraneous factors are those factors which affect relationship between dependent and independent variables, and there are several extraneous factors. The sample sizes must be the same for paired sample. Of course, it has to be there for paired sample B and C, but not A. So, the answer is B. We always use paired sample so that we can remove the effect of extraneous factors, right. So, it allows us to control for extraneous factors. Let us look at 24th. A set of two dependent samples of size 15. A set of two dependent samples of size 15 was taken and a hypothesis test was performed. T value with 14 degrees of freedom was used because n minus 1, right. So, that is why 14 degrees of use. If two sets of sample had been treated as independent sample, how many degrees of freedom would have been used? So, it was n1 plus n2 minus 2, is not it. So, 15 plus 15 minus 2, it is 28. So, B is the correct answer for this. B is correct answer. Okay. Let us look at 25th. A farmer has 12 fields of corn in different parts of certain country, testing for significantly different yields from year to year. He checks his records for the past 2 years and is able to gather information about production in 11 of the fields for the first years and second year. Should he treat these samples as dependent, independent, cannot be determined from information? See, for having dependent sample, you should have data collected before and after, right. So, if you had, let us say, data of all 11 fields, then it would have become dependent. In case of independent, again initially in this question it is written that a farmer has 12 fields, but information is all available only on about 11. So, it can't be independent, right. So, answer is C, cannot be determined from information given, right. Let us look at 26th one. In a test of difference between proportions, right, two samples are under consideration. In first sample, the size is 100. So, n1 is this, shows 20 successes. So, x1 20. In the second sample, this was 50 and x2 13, right. So, the value of p hat will be, it was x1 plus x2 divided by n1 plus n2, is not it. So, this is 33 by 50, right. So, A is the correct answer for this. Let us look at 27th number. What is the major assumption we made when performing one tail test for differences between means with small samples? Major assumption. What is the major assumption we made when performing one tail test for differences between means with small samples? Unknown population variances were equal. So, unknown population variances were equal. Sampling fractions were quite small. The sample were chosen using judgmental sampling technique, and none of this. So, the answer to 27th is, of course, A. This is what we have assumed, that the population variances were unknown and equal, right. Let us look at next question, 28th. Airline A and airline B boast successful baggage routing rates of 98% and 95%, right. So, 95% and 98%. From this information we can determine airline A has better baggage service, airline B has better baggage service, the baggage services are actually accurate, nothing, we need more information. Yes. So, for this question we need more information, right. So, if we had the idea of, let us say, alpha, then we would have checked whether the performance is more in airline B or not, right. So, you would have had P 1 is equal to 0.95, P 2 is equal to 0.92, right, and you could have framed, let us say P 1 less than P 2, right. Okay. A two-tailed test of difference between two proportion led to 1.85 for its standardized difference of sample proportions. For which of the following significance level would you reject? So, you just look at Z table and you can find out answer to this question. I am skipping this question. Let P be the probe value for a given upper tail test hypothesis, alpha be the significance level, T critic be the critical value of test, T obs is the standardized test statistics. You will accept null hypothesis if these two are correct. So, answer to this is D. So, B and C, but not A, right. Let us look at next question. You wish to test whether the mean of population 2 is at least 10 more than the mean of population 1. So, mean of population 2 is higher, right. You wish to test whether the mean of population 2 is at least 10 more than mean of population 1, right. What value of mu 1 minus mu 2 you should use when computing standardized statistics. So, in this case you will be using this, right, mu 1 minus mu 2 is equal to minus 10, right, then only this statement would become correct, right. For which of the following is a test of difference of proportion not appropriate? For which of the following is a test of difference of proportions not appropriate, seeing whether the fractions of waste produced by two processes are the same, seeing, right, deciding whether the fraction of women in two grades at school are the same, deciding whether fractions of women in two grades at school are the same, testing whether different proportion of people in Boston and Chicago like NBA basketball, seeing whether Ford owners have more brand loyalty than Honda owners. So, answer to this is A. So, fraction of waste produced by two processes are the same, you can't have this kind of situation if this statement is true. So, for which of the following is a test of difference of proportion not appropriate? So, seeing whether the fraction of waste produced by two processes. Okay. Let us look at next one. Of course, you would be requiring table for this. So, you can, in fact, you have the formula for this, right, pooled variance. So, just put these values in formula, you will get the answer, right. For which of the following is a two sample test not appropriate? For which of the following is two sample test not appropriate, right? Not appropriate. Seeing whether the proportion of childless couples and couples with children who buy sports cars are different. Here we are not saying whether it is a two sample test or we are not saying whether it is means or proportion or variance, right. Which of the following is a two sample test not appropriate? Seeing whether the proportion of childless couples and couples with children who buy sports car are different. Seeing whether the mean beer consumption is higher in Germany than France. Testing whether there are more men than women in Alaska. Deciding whether average attendance at major large baseball game is same in Los Angeles as San Francisco. So, the correct answer for this is C. So, let us look at these two questions and then we will finish this session. For an upper tailed test of the difference of two means based on dependent sample of size this alpha this, the critical value of test statistics. Just look at T table, you will get the answer. Which of the following tests could be used on the normal distribution? Difference between independent means, difference between dependent means, difference between proportions, all of these or this. So, the answer to this question is all of these. So, with this let me finish today's session. In this session we have worked out couple of examples on hypothesis testing and we have refreshed the concepts related to hypothesis testing. Thank you very much.